Hello, everyone, and welcome back to the 2020 Bibliometrics and Research Assessment Symposium. My name is Chris Belter. I am the host, or one of the hosts for our symposium today, and we've made it to our final session of the day. So congratulations to everyone for sticking it out with us or coming back to us to join us for the final session of the day. We're really pleased to have Karen Gutzman talk us through VOSViewer. But before we get there, I have just a couple of quick announcements that I wanted to make before we got started. So as I mentioned, we are recording the sessions, but we're not recording the attendees of the chat. So you can feel free to participate without worrying about being part of the recording. Audio is for attendees is in broadcast only, so you don't need to join the audio session, and all attendees are muted. We are handling all questions through the chat box. So if you have any questions for the speakers or the presenters, please use the chat box and please send your messages to everyone. We have had a number of folks sending chat messages to hosts or panelists or presenters, and sometimes those messages can get lost. We do have attendees who are monitoring the chat. So please, if you want your question actually addressed, please send your chat message to everyone and we'll get it taken care of. Finally, live captions are available in the multimedia viewer panel, so go ahead and just open up that and you'll be able to get to the captions. So for our final session of the day, we have Karen Gutzman, who you heard from on our panel earlier. But this time she's back to talk about VOSViewer. So she's from the Northwestern University. And again, she's going to take us through how to use VOSViewer. So Karen, are you there?
I'm here.
Fantastic.
So I'm just going to get my slides up and going.
Yep.
All right. Hopefully you all can see my slides.
Yep, everything looks good.
All right, great. Okay. So before we get started, I just want to let you know that there is a box folder where the presentation slides and some helpful files live, and that I actually have a recording of today's lecture in there too, because any of you might have also pandemic anxiety and like to record things ahead of time just in case. So that is available to you as well. And also today's presentation is fairly scripted just because we have a lot to get through in an hour, and I didn't want my chattiness to get in the way of making sure that we can cover as much as possible. So without further ado, welcome. Again, my name is Karen Gutzman, and I serve as the Head of Research Assessment and Communications at Galter Health Sciences Library and Learning Center at the Feinberg School of Medicine, Northwestern University, located in Chicago, Illinois. They say a picture is worth 1,000 words, and in the field of research assessment, bibliographic and bibliometric networks are an important tool to demonstrate the collaboration patterns of an institution, the topical coverage of a research program, the key articles in a field of research, and so much more. So today's class will provide a basic overview of VOSViewer, a software tool for constructing and visualizing bibliographic and bibliometric networks with a user-friendly interface. We will cover the basic workflow for creating network maps in VOSViewer, beginning with the term co-occurrence network, and if time permits, we'll discuss other network types as well. Today, I will demonstrate for you installing and opening VOSViewer, options for importing data into VOSViewer, and how to create a term co-occurrence network, how to use various overlays on that network, how to make changes to the network layout and appearance, and how to use a thesaurus file to edit the network data. Finally, I'll show examples of networks that I've created and discuss using legends and provide examples of narratives used to describe these networks. So I want to cover some basic terminology that you may hear in the class today, or that you may see in the literature or other software. So please refer back to the slide throughout the course as needed. So today I will refer to a data set, meaning a group of documents being analyzed by VOSViewer. A document can be represented by its title, its abstract, or the concatenation or combination of its title and abstract. This is actually an option you will choose as you create the network. Networks and maps refer to the visualization of a set of items with links between the items. Networks and maps will be used interchangeably as words today. You may also see a network or map referred to as a graph in the literature. Circles in a network or map represent items. Today, these items are terms in the term co-occurrence map. They also are referred to as nodes, which you might even see as the term vertex in some software. Lines in the network might also be referred to as links or edges between items. And the strength of a link between two nodes might be referred to as the line thickness or the edge weight. So for the sake of time today, because we only have an hour, I'm going to walk through on my slides how to install VOSViewer. But later in the class, I will actually use VOSViewer to create a term co-occurrence map. If you already have VOSViewer installed on your computer, you may wish to follow along with today's instruction in VOSViewer itself. If you have not yet installed VOSViewer, just given the time constraints of today and whether or not you have 2 monitors or however that might work for you, you may just want to watch my screen and return to a recording of this class once you've had ample time to install VOSViewer on your computer. So current version of VOSViewer at the time of this class is 6.15. You should install the most recent version available. So to install VOSViewer, you're going to go to www.vosviewer.com. You will click on the Download VOSViewer link. You will select the Download VOSViewer link for Windows, Mac, or other systems based on which one matches your computer. I am using a Windows computer. The next step provided in VOSViewer's workflow or in their download instructions explains that you should create a new folder and unpack the downloaded zip file. So for those of you not familiar with this, many programs have an automatic installer that creates a folder for you in your Windows C drive under the Program Files or the Program Files 86 folder. But VOSViewer doesn't have that installer and instead allows you to decide where the files, including that executable file that runs VOSViewer, should live on your computer. So I'll explain my process for installing tools like VOSViewer, which don't have that automatic installer that creates that folder. But please follow whatever your normal workflow is for deciding where to install new programs. So I go to the Windows C drive, I click on Users, and then I click on my username because there are several users that have access to my computer. And then you can see under my users, I've actually created a folder called Tools. This is where I install programs like VOSViewer. So in the Tools folder is where then I will create a folder, a new folder that I will call VOSViewer. I can go back to my Downloads folder where I had just downloaded the VOSViewer file. I can right-click on that VOSViewer zip file and select Extract All. Then browse my way into the VOSViewer folder that I have created, and then I can finally click on Extract to extract those VOSViewer files into that folder. To open VOSViewer, I can then navigate to the folder where I stored VOSViewer, double-click on the application file that's actually called VOSViewer, and it's also known as an executable file. It's what will run the program. You might consider creating a shortcut to this VOSViewer file on your desktop, and on a Windows machine, it's a right-click, and then you create shortcut to desktop. Okay, so I know that process might take a while for everybody. And like I said, you can always return to recording. There is a recording available in Box of this presentation. And I can't promise that it will go easily for everyone, but generally it's not too difficult to download VOSViewer. So now that we have VOSViewer installed, we can begin visualizing text data in network. So on my screen, I have some data. So let's say we want to visually represent the documents of 6 researchers who work on public health topics using a term co-occurrence network in VOSViewer. Today, we'll use publication data from Scopus, but for the term co-occurrence maps, VOSViewer accepts data from Web of Science, Scopus, Dimensions, PubMed, and some others. And we'll discuss data sources near the end of today's class. So if you don't have access to Scopus normally, but you would maybe have access to one of these other sources like maybe PubMed or Web of Science, or even the free version of Dimensions, then you can use that data for a term co-occurrence network. As I mentioned, we'll be using a test data set from Scopus. If you want to retrieve the test data from Scopus, you can copy and paste the search terms for the Scopus author IDs that I have on this slide into Scopus's advanced search. Then you can select all the documents and choose export. Be sure to select CSV as the export method, and make sure you select citation information, bibliographic information, abstracts, and keywords, and include references. This information will give you a flexible data set from which you can create several types of maps in VOSViewer, beyond even the term co-occurrence network that we're covering today. If you don't have access to Scopus and you want to use the same data set that we're using in today's class, you can download the data file from the box link that's provided on this slide, and it's a similar link to the box link that was provided in the chat and on Slack. So I'm actually going to go ahead and move away from my slides and open Scopus and just show you really quickly how you might get that data from Scopus. So I have Scopus open, and I'm going to navigate to the advanced section. I'm going to go ahead and copy in my author ID search string for the authors that I'm interested in. Click on search. I got an error. I'm going to close Scopus and open it again from my library's website. There we go. Okay, there it is. There's my search. I'm in advanced. I'm going to search. Okay, so now I have the 624 documents that I am interested in from the 6 researchers that I mentioned. I could go ahead and refine those results, perhaps by year or document type, maybe even publication stage if I don't want any of those, early access articles in there. But I don't actually want to see everything in this analysis. And I'm going to go ahead and select all of the documents, all 624, and I'm going to export them. I will choose the CSV option. I will choose not only all the citation information, but all the bibliographical information, the abstract and keywords, and also include references. Like I said, this will give you the broadest data set to use from Scopus in VOSViewer and create other maps than just the term co-occurrence map. So then you go ahead and click export. And then you'll want to save that file somewhere where you remember that you can find it again, because you'll need to find it when you're in VOSViewer, and make sure you save it as a CSV. All right, so mine's going to open, but I already have it saved somewhere. So really back to my slides really quickly here. Hopefully, there we go. Okay, so actually the next step we're going to do is we're going to open VOSViewer. I'm going to close this, and I'm going to navigate to my VOSViewer and open it. It opened on my other screen, but there it is here for you. So this is actually as large as I can get VOSViewer. So I realize that some of these buttons are a little small, and I apologize for that. But I have tried to make my mouse a little bit bigger, so hopefully you can kind of see the general area in which my mouse is clicking as I go through. So I do have So with VOSViewer, we can now create our term co-occurrence map. In the VOSViewer window, if we look to the left, you can actually see under this info section that there is access to a manual. And this is really helpful. So a lot of the content for this presentation comes directly from this manual. And so I'm not going to be using my slides directly for this portion. I'm going to be using VOSViewer, but please note that there's more information on my slides, should you find that helpful, or you can go directly into the manual itself and use that. Okay, so to get started creating our map, we're going to go up to this map section and click on Create. And that button brings up what's called the Create Map Wizard. Apologize because everything is opening on my other screen, but I will just drag it over here as we go. So the very first thing we need to do is choose the type of data that we're working with. We are actually going to choose Create Map based on text data. Please note that VOSViewer assumes that the text data is going to be in English, and also note that creating maps using text data works best when we have data sets of about 100 or more. And that's just because larger data sets tend to yield more interesting maps. So if you have really small data sets, it's okay, you can still create a map. You're just going to notice that there aren't maybe a lot of terms that it's been able to pull out. You might have to adjust some of the amount of terms that you allow in the map, which we will cover in the upcoming workflow. So bigger or larger data sets generally tend to yield more interesting results. We will briefly cover other types of data and maps available in VOSViewer, some of these other things that you see towards the end of the class. We're going to click next. So now we need to choose the data source, and we will choose read data from bibliographic databases, all right? Bibliographic database files. So the supported file types are Web of Science, Scopus, Dimensions, and PubMed. And this is how now we are going to click next and then open that CSV that we saved from Scopus. So I'm choosing Scopus here, and then I'm going to go ahead and navigate to the Scopus file. So I have a little bit of navigation here to do. I'm going to pull this over so you can see. I'm just navigating to where I saved my file that I downloaded from Scopus. So here it is. You can name it whatever you like. So yours probably isn't named the same as mine. And then we're going to go ahead and click next. Now, if you were to try to upload this Scopus file under Web of Science or Dimensions or PubMed, you're going to get an error because VOSViewer is actually looking for very specific column headers that it will expect to see from Scopus or from Web of Science or Dimensions or PubMed. So you do need to make sure that you get this correct. If you don't, that's fine. Just start over, click on the database or the data, the database that you're using, and then move ahead. Okay, so we then next need to choose the fields from which the terms will be extracted. We're going to choose title and abstract fields. These fields will then be concatenated or combined together to represent the text of a document. We will also keep checked ignore structured abstract labels so that those commonly used section labels for structured abstracts are going to be ignored. We are also going to keep check ignore copyright statements. It's really helpful because that's going to ignore those copyright statements that are often found at the end of abstracts. Okay, so then we're going to click next. So now it's extracting terms. I'm going to go through briefly what that means, but please know that you can refer to the manual and all of the references that they have provided to understand what it means to extract terms from a document set. So there are actually 5 steps that VOSViewer goes through to identify those terms. The first is they remove the copyright statements if you checked that box in the workflow. Then it uses an algorithm from the Apache Open NLP library to do sentence detection. So it actually splits the data into sentences. Next is the parts of speech tagging. So again, uses an algorithm from that Apache Open NLP library to assign each word to a part of speech, such as this is a verb or a noun or an adjective or preposition and so on. Then there comes noun phrase identification. So a noun phrase is just a sequence of one or more consecutive words within a sentence, such as the last word of the sequence is a noun, and each of the other words is either a noun or an adjective. Just note for later on, or just in your mind, remember that VOSViewer considers only the longest possible noun phrases that can be found in a sentence. So you will see multi-phrase nouns in your results, or sorry, multi-word phrases in your results. And VOSViewer doesn't consider noun phrase if it includes a preposition. So degrees of freedom and United States of America are not considered noun phrases because they do have that preposition in them. And then the last thing that's done is this unification, right? Because it needs to start counting the number of noun phrases that it found. And so it will remove most of the non-alphanumeric characters, not all of them. You'll see some in there, especially for like medical terms. It will remove accents from characters. It'll convert uppercase characters to lowercase, and it will convert plural noun phrases to singular. Again, if you have any questions about that process, I refer you back to the manual and to the references that they provide. Okay, so that was a long way to get us to this next part, which is to choose your counting method. So now the terms have been extracted, and we have 2 options for choosing a counting method. The first is binary counting, where only the presence or the absence of a term in a document matters. So the number of occurrences of a term in a document is not taken into consideration. The binary counting option simply counts the number of documents in which a term occurs at least once. okay? So then the other option is full counting, where all occurrences of a term in a document are counted. Today, we're going to choose the binary counting method, but I suggest you explore both options later on. And then also just note here that there is an option to upload what's called a VOSViewer thesaurus file. This is a file that you will create to help indicate merging of nodes or removal of nodes. So we're not going to do that right now because we actually haven't seen our maps. We have no idea what needs to be done. But we will go through it at the end of the class. So remember this step because that's where your thesaurus file can go, okay? All right, so we're going to go ahead and click Next. Now we choose the threshold. The threshold is the minimum number of occurrences of a term for inclusion in the map. 10 is the default number, but it can be changed. So if you wanted to include all 12,979 terms in the map, you would basically want to say that a term can occur once and it's fine, please include it. There's actually another step that would kind of prevent that from happening because you will get a spaghetti bowl effect where you won't be able to see really anything. But note that you can change this number up or down. Remember, if you chose binary counting, this means that the term has to be present in at least 10 documents to be included in the map. If you chose full counting, this means the term has to occur at least 10 times in any individual document or in the group of documents, whatever that is, to be included in the map. So also at this point, consider recording this number. That's the total number of terms found because you might want to report on it later just for your own purposes of like how many terms were found in this data set. Okay, so we're going to go ahead and click Next. So now this says choose the number of terms. So here it's good to note that VOSViewer calculates a relevance score for each of its terms. You can refer again to the manual and the references provided for how that score is calculated, but just note that terms with a high relevance score tend to be to represent more specific topics covered in the textual data, and they really focus the map on those more specific and more informative terms. So general terms that are often found in the literature like conclusion or new method or interesting result really provide very little information and will receive a lower relevance score, so then you wouldn't necessarily want them. You can adjust the number of terms to be selected. You can adjust that here. And in today's example, we're just going to use the number that's provided. And it's always a good idea to consider recording the number of terms to be selected so you can report on it later. So this will be the number of terms that is in your map, okay? Unless we get to the next step, so now it's actually calculating those relevance scores. So VOSViewer then allows you to view the terms, so here are the terms that were found, the occurrences, and their relevance score. In this step, then, you can check or uncheck terms to be included in the map. However, this is important to remember, unchecking or excluding those longer terms may increase counts of those shorter phrases. So when one chooses to exclude a multi-word term, occurrences of this term may be counted as occurrences of a shorter term. So here's an example that VOSViewer gives in their manual. If you exclude the term artificial neural network, which is found perhaps in the sentence, the artificial neural network is highly accurate, VOSViewer then searches for a shorter term in the sentence, and it will find neural network. So it will then count it as neural network. If you choose to exclude neural network, then VOSViewer is going to actually search for an even shorter term, and it's going to find network, and it's going to count network. So just note that at this step, it's not as clear-cut as you think to remove or add terms, because you might actually be increasing counts of others, which is maybe not something that's a bad thing you might want, but just note that. And also, it can be, just a lot to come in here and work on these boxes. So I just want to mention that another option for reviewing and controlling the terms in the map is to create a VOSViewer thesaurus file. It's also a bit of work, but it is helpful in merging or removing nodes if you want. So we'll discuss this later, but you can use it, again, to merge terms or remove specific terms altogether from your map. So we're going to click Finish because now we actually have gotten to the end of this Create Map Wizard. and hopefully we will see our network. Awesome. Okay, so the first map that we see is called the network visualization. You can see that in the tab up here. Items are represented by their label and also by a circle. The color represents the cluster to which the item belongs. You can see some different colors here. You can review the manual for information about the clustering algorithm. The circle size is determined by the weight of the items, and we'll talk about all the different weights that are calculated in just a minute. The labels for some items may not be displayed to avoid overlapping labels, so that can be a bit difficult, but again, it's just optimized for viewing. Lines between the circles represent links between items. The thicker the line, the more often the terms are used together in the data set. The layout of the circles represents how related the items are. So the distance between two terms indicates how often they co-occur in the data set. So as you can imagine, the smaller the distance, the larger the number of co-occurrences, and the stronger the terms are related to each other. All right, so we are actually going to now talk about some changes that you can make to this. So we're going to look over here at this visualization box. So the scale slider, I'm just going to move that around so you can see some of the changes, actually determines the size of the labels and the items in the map and the thickness of the lines used to display the links between the items. The weights here, so VOSViewer calculates 3 weight attributes for each term. The weight attributes can determine how prominently those items are shown in the map. So you have 3 options. The first one is actually occurrences, which is the default option, and refers to the number of occurrences of a term in a data set. Remember that your choice of binary counting or full counting impacts this number. The second option is links. We'll just look at links really quick. Links is the number of unique connections a term has with other terms in the network. And then the third option is total link strength, which is the total number of links a term has with another in the map. So there is a difference between link and total link strength. So for example, let's say term A was used with term B, and they were actually used together in 3 documents. The link count for term A would be 1, but the total link strength for term A would be 3 because it was used with B 3 times, okay? So that's the difference there. Then we have the label section. Again, you have a slider to change the size of the label, okay? And I'm actually gonna just set this back to occurrence. I like to kind of reset things here. Okay, so you can change the slider so that the higher the weight of the item, the larger the label. You can actually change between circles and frames if you just want to break it up a bit here. And then the max length, this is kind of nice, determines the max length of the label being displayed. So I always like to increase this, I mean, that's just me, so that I can actually see the full label of the node. So you can choose, and then you can actually choose to change the font. The last section here we're going to look at, second to last section here, sorry, is the lines. So again, the size we covered that. Sorry, next section. So you can also change the cluster, you can change the min strength and max strength for lines that are shown. So if you see this, you can actually increase, the minimum strength at which the lines will be shown or the max. I always like to just increase it to see, how that's going to change my view. And so now I see more lines. So there are more lines than what were being displayed simply because it can really be a lot for the eyes. So you can actually increase or decrease. And, it's up to you to decide how this works or if you even want to show lines at all. You can show this in a lot of different ways. And then those lines that you show can be either, let's see, I'll put this out back in there, can be curved or they can be straight. And then finally, you can change the cluster colors and you can actually import colors, export colors. So this can be really helpful if you're, for instance, wanting to use your own set of colors for these clusters, and then you can choose to have a black background or not. Okay, so that's the network visualization and some of your options there. We're going to talk next about the overlay visualization. So the overlay visualization is going to actually, it's going to be identical to the network visualization, except for the items are now colored differently. So in an overlay, the color of the item is determined by the score, of the item, and we'll talk about those scores in a minute. The default colors are generally blue would be the lowest score, to green, to yellow, where yellow is the highest score. So there are 3 scores, and we actually see them here, and we can choose now which score we want to show. So average publication year is, again, the average publication year of the documents in which the term occurs. You can see terms that occur more likely in documents that are, in this case, closer on average to 2017, or older terms. You can kind of see the evolution of topics in these documents. You can see average citations. This is the average number of citations received to the documents in which the term occurs. And this is because we actually provided a citation count in that Scopus data, so VOSViewer can calculate this. We can look at average normalized citations, and so we've heard somewhat about those normalized citation counts. And so the average normalized number of citations received by the documents in which the term occurs, that's what that score is, it's typically calculated by taking the actual number of citations received by the document in which the term occurs, dividing it by the average number of citations received by the data set. And so anything above 1 is more highly cited than the average term in the data set, and anything less than 1 is less highly cited than the average term in the data set. And so then you can see that scale down here. Okay. All right, so that is the overlay visualization. And now we're going to look at the density visualization. This one, if you ever print it out, really heavy on the colors, right? So again, same as the network and the overlay, but now we're seeing that each point in the item density visualization has a color that indicates the density of items at that point. So by default, the colors range from blue to green to yellow. The larger the number of items in the neighborhood of a point and the higher the weight of the neighboring items, the closer it is to yellow, so it's more dense. The other way around would be the smaller the number of items in the neighborhood of a point and the lower the weight of the neighboring items, the closer the point is to blue. And so you do have the weights that you can look at here and see where a lot of the links are happening or the link strength and so on. So I encourage you to kind of play around with these different overlays. The one thing about the density overlay is that you can actually change the colors. So they have some nice little color options here underneath. Use predefined colors. Again, you can import colors, you can actually export colors and such. So there's a lot you can do there. Okay, so I'm just going to click back on the network visualization. So we're seeing that again, just so don't burn our eyeballs out with all that blue. And we are now going to look at the Items tab. So the Items tab presents a list of items in the currently active map. By default, it's going to list all of the items, as you can see, but you can filter through that. So if I were to put in the term diabetes, it's going to show me all of the items that have diabetes in the phrase. And you can actually double click on any of these items and it will show it to you, here it is, in the map. So you can actually find it. And then I'm just going to scroll out so that we, and you can scroll out or zoom or whatever, and you can move things around. So the other thing to note in this item filter is the group items by cluster. So if it is checked, then the items are first grouped by their cluster and then listed alphabetically within their cluster. If unchecked, it just shows all items. Another thing to note is that when you are, looking at any particular item, when you select it, you can actually see some of that information about that item down here. So we can see I'm looking at the item early adulthood. It's part of cluster number 1. It has 78 links. Not all of them are obviously showing because I have put my max at 1,000. Total link strength is 178. So it's used more than once, obviously, with some of the terms that it's linked to. And it occurs 14 times. So there you go. That's kind of helpful. And that was, sorry, that was right down here if you can't see where I was referring to. Okay, so then the next tab is the Analysis tab. And oh boy, I cannot cover everything in the Analysis tab in this class, nor do I actually understand all of it because a lot of these methods take a little bit of time and reading to really dig into. So what I'm going to tell you is that if you are very curious about these methods, please refer to the manual and the references in there, especially if you're going to start looking at this for any kind of scientific analysis. It's really just a font of information. Or take the VOSViewer class that I'm going to mention at the end of this, the official VOSViewer class by the instructors who created this tool. So basically under normalization, it allows you to determine how the strength of the links between the items is normalized. You have some different methods that you can choose. You can also look at the layout, and you can play around with the attractions and the repulsion values. I'm going to stick with the default values, but that's something you can actually work around with. There are some advanced parameters, and then obviously this button helps you update the layout as you choose or as you change any of these. The clustering section allows you to change the resolutions of the clusters, the minimum cluster size, and the ability to merge those small clusters. And we are actually merging the small clusters right now, but this, again, something that you can play around with, and then you can always update the clustering to see how it makes some changes. You can also rotate and flip and change the map around as much as you want here and kind of get it into the shape that you would like to see it in. All right, so I see this might have come up as a question. I'm not able to see the chat as I'm sharing my screen very well, but somebody asked, I think, about saving or things like that. So great question. We're going to go back to the File tab, and we already talked about Create. We haven't mentioned Open yet, but we'll talk about it in a second. You can save the underlying file. Okay, so I'm just going to mention here, you can save, oh, here, I got to drag this over. You can save the underlying file. So there are two files that make up this particular network. There's the map file and there's the network file. We are actually going to look at the map file in a little bit so you can see what info is there. So this is like has the weights and the scores and the listing of the items. The network file, just as important, actually shows you or tells you what the links between those nodes are. It's a very basic file. It just says, you know, for instance, baseline is maybe has an ID of 1, and let's say it's connected to smoking, and so it just says that there is a link between baseline and smoking. So basically tells you where those links are. So you will probably at some point want to just save both of those off as text files. Again, you can open them in Excel to look at them a little bit more easily. You also have the option of saving it as a GML file. This is really helpful for those of you who like to use Gephi, for example, so that you can then actually put this into Gephi and use the network in there. There's also Payek. For those of you who use network software like Payek and you want to play around with it in that format, you can do that. If you don't know what those two are, don't worry about it. You're a VOSViewer, you're going to be okay. So that's an option. If you just want a nice little shot here, you can save a screenshot. So I'm going to mention that you can save it, and of course, everything opening on my other window here. You can save it as a PNG, you can save it as an SVG, JPEG, whatever you'd like. The options are there. And then also, if you just use this little drop down, you can print it, you can copy it to a clipboard, and you have a couple of options that are kind of nice to have. You can change the scaling of the network as you're saving it. You can optimize the labeling or not optimize it, which basically helps you see or not see some of those labels that exist. You can include a border, and you can include a transparent background, which would help you then if you need that. If you're going to open it maybe in Adobe Illustrator or PowerPoint or something like that later on, and you want some of these options. Okay. So next up, I'm actually going to go back to my slides because I want to show you the map file, and I just have a little overview of it here. So why I'm showing this is because it's very helpful, I think, to see what is calculated and how you can actually see that in a, I just love to look at these Excel files, and because sometimes you can infer some information that's a little bit harder to do in the interface. So the first is here's an example. So the first is the ID column, and this is basically lets you know what the ID of this is. So if you were to look in the network file, you would not see the label name. You actually see it as an ID. ID1 is connected to ID2. ID3 is connected to ID1, and that's what you see in that network file. The label is obviously the label given to the item. If you wanted to change or update the label, let's say you want them to be capitalized or something of that nature, you actually need to make the change in the map file. And then when you want to recreate the map so that you can now see these updated labels, again, don't make too many changes. Generally, don't like change the whole name of it or anything like that. But if you wanted to, like, you know, if this was someone's name and you wanted to capitalize it or something like that, then you save the map file, you'd go through the open process, and you would reload your map file and your network file, and you would see now the capitalized label. We'll talk about the source file in a minute, which is how you actually merge nodes. You don't do that in the map file. Don't do that in the map file. You then also have the X and the Y coordinates. This is something else that you can play around with. Again, you lose then the connection. So in the visual of the map, the connection or the distance of two terms is based on how related they are. So once you start playing around with the X and Y coordinates and moving things around the map, you're actually going to lose that piece of information. But, you know, it's up to you. This is why I give you the ability to edit these things. You can actually edit the cluster number. So if you wanted to create your own clusters for some reason, you could do that. But here it just shows you the clusters. Also, you can actually sort this by cluster, so you can see the top terms in each cluster, which is really helpful. Again, it's not always for editing. Sometimes it's just for analysis that you want to look at these things. Weight links is, again, the number of unique occurrences in which a term occurred with other terms. So, for instance, ability has the weight link of 110, which means it co-occurred with 110 unique terms in the data set. Or basically, ability has 110 individual lines drawn out to other terms. Weight total link strength is the total number of occurrences in which a term occurred with another term. So, for instance, ability has the weight total link strength of 184, which means that ability actually co-occurred with a total of 184 times with other terms, which means that it co-occurred with another term more than once, right? Because we can see that because it's actually more than the links. Weight occurrences, we've talked about this, is the number of occurrences of a term in a group of documents, which can be impacted by the counting method you chose. And then we get to our scores. Remember, there's 3 scores that it calculates: average pub year, which is the average publication year of the documents in which the term occurred. The score average citations, this is the average number of citations received by the documents in which the term occurred. Average normalized citation, which is the average number of citations received by the documents in which the term occurred. So it's an average, it's that score that you receive is greater than 1 or less than 1. Okay. All right, so that was the map file. And just for the sake of time, I'm sorry we are blazing through this, but I just want to mention the source file because I found it so helpful once I realized it existed. A thesaurus file is a text file or a CSV file that can be used to perform data cleaning when creating a map. And you can create and upload this source file during that counting method, or sorry, you can upload it during that counting method portion of the map. It's a very simple file. It has 2 columns, a label column and a replace by column. So in this example, and I'm just going to go ahead and get my map up here really quickly. We have, I'm looking at this, I'm like, oh, we have BMI, and we also have body mass index. And I will note that in this case, I know those terms are the same. I can actually do a search in the title and abstracts of my documents and identify that BMI was never used for anything other than to refer to body mass index. And so, and let me tell you, that can get really tricky with large data sets. People use abbreviations for things you had have never believed they would. So, but in this case, I'm very certain that I can actually merge these 2 nodes. Again, be very careful when you start merging nodes or telling people that you can do that, especially if you're not a subject expert. But in this case, I'm going to go for it. I'm going to say they can be merged. And also, I see the term December here, and I just, you know, I don't want that term on my map or whatever, for whatever reason, it just doesn't need to be there. So what I'm going to do is I'm going to show you, sorry, go back to my slides here really quick. So I'm actually going to take a very simple thesaurus file, literally says label, and it says BMI, and replaced by body mass index. And so what that's actually telling VOSViewer is that I'm seeing this label BMI, and I would like to replace it by body mass index. And since body mass index actually already occurs it's going to merge the two. It's going to merge the two. So that's important to know. If I just wanted to change the label BMI to body mass index so that I would have two different body mass indexes on my map, I would actually do that in the map file. I would go find BMI in that list and I would change the name of it. But no, this I want to merge, so I need to do it in the thesaurus file. And then December, I want to get rid of it. Again, it's going to get rid of all occurrences of December, so make sure that's something you really want to do. So I have the label and I replace it by nothing. Okay, so now it's going to ignore December. We're actually going to walk through the steps of how you would do this. So I have a thesaurus file that I have already created. I'll open it here so you can see it. Again, it's just a simple file. I saved it as a CSV, label replaced by BMI body mass index, and then December. So I'm going to go back through and show you how to upload this. I will mention that you really don't want to make any edits to your map file until you have done everything you need to do in your thesaurus file. And that's because every time you use a thesaurus file, you're changing the map file. And you would then need to go through and re-edit it. You'll see that as you work more with VOSViewer, kind of what the workflow is and how you're going to best spend your time. So, okay. So in order to use a thesaurus file, I actually have to go through the steps to create a brand new map. So I'm going to click on Create. I'm going to, again, text data, bibliographic databases, Scopus. I'm doing all the same parameters, but now here's where I'm going to upload my thesaurus file. So you're going to watch me kind of, actually have it saved as a CSV. So there it is. There's my thesaurus file. And I'm going to go ahead and finish all the way through here. I don't even, not making any changes to that. And so now you see I no longer have BMI. I just have body mass index, and there's no more December, right? So that's how I made those changes. Okay, go back to my slides really quickly. So that's the thesaurus file. You guys can hear me trip over that every time I say it. Okay, so here's the networks that I've done. So this is how I presented some of the maps. I usually present them in PowerPoint. I just find it to work best, but you probably all have your own workflows and ways that work best for you. In this case, I actually asked the subject expert to look at the clusters. I gave them the different clusters, sorted them so they could see what was at the top, the highest occurrences in that cluster. They said, if you had to name this, what would it be? I do not envy anyone that has to do this. And if anyone has a good tool or something that they like to use, let me know for naming clusters. But I think it's kind of a bit of difficult, right? It's difficult because people could look at this and come up with two different names. So it's not something that I would recommend doing lightly. But in this case, we got some names for these clusters. And so then we actually provide a note section, which is in my slides, where we basically say, this term co-occurrence map indicates major research topics in the articles and reviews published by our entire research community in the past year. Major topical areas include behavioral and rehabilitative medicine, cardiovascular disease and epidemiology, immunology and molecular genetics, public health and preventive medicine. This term co-occurrence map displays 409 terms from the titles and abstracts of publications from 2017 to 2018. By the entire research community visualized using the VOSViewer software. All terms are assigned and colored accordingly to a cluster by a computer clustering algorithm. After reviewing the terms, titles were identified to describe each cluster. Term bubbles are sized by the number of times they occur in the title or abstract of a publication. The larger the term, the more the occurrences. Each term occurs in at least 10 publications. Lines between terms indicate when terms are used together in the title or abstract. The distance between the two terms indicates how often the terms co-occur in the title or abstract. The smaller the distance, the larger the number of co-occurrences, and the stronger the terms are related to each other. The thicker the line, the more often the terms are used together. So that's kind of my standard spiel that I use. You all could probably come up with something a little shorter, but there you go. There's an option for you. This is an example where it's the same map, just like simple cluster names. In this map, we wanted to highlight some of the terms retrieved by VOSViewer. Again, we did all of this in PowerPoint, so nothing special here, other than just like, your use of PowerPoint. So we wanted to highlight some of the terms retrieved by VOSViewer that were important to this particular community. So we showed the connection of two important terms, which have to do response and risk factor, with other terms in the map. And then we also, so we can see how we just highlighted one and took a screenshot. We also included two of the papers in which these terms may have been retrieved by VOSViewer by looking at the titles in the abstract. Okay, and that's how we got those terms. And then we provided those citations on the map. Again, this is not like perfect, but it's just giving you a little bit more understanding of how this map is created. Okay, so this is another one. I just wanted to show you where we made legends. So we actually just went ahead and went into that map file. And like, for instance, we'd look at the circle for participant. We drew a circle the size of participant and looked to see how many occurrences it had. And then we tried to find something that was like a medium amount of occurrences and find that and size the circle and then small. You have to be careful because now when you resize the map, you have to resize the circle so that it goes along with it. But it just helps the eye understand kind of what are we talking about here? How many terms? You can also do this for lines. We didn't in this case, but if you get some really thick lines in there and you want to show, for instance, two authors working together, you can do that. All right, I got a book because we're getting towards the end of this here. So there are other network and map types. So we have the co-authorship map. So these is where your nodes are going to be author names from documents in the data set, and your lines are going to be linking authors to a co-authored document. Again, make sure that you have those author lists in your data set so that VOSViewer can do this. A co-occurrence map. So you can actually analyze, again, we did terms, but you can do keywords, author keywords, or index keywords. So your nodes then are going to be keywords pulled from the column of keywords that you gave it from like Scopus or Web of Science or what have you. And then the links are going to be keywords that have been used together in a document. Again, you have to have those keywords in there to do that in that data set. A citation map. You can analyze documents, sources, authors, organizations, countries. So if you're doing documents, the nodes are going to be documents from the data set, and the lines are going to be linking documents in the data set that have been cited, that have cited each other. You have to have that cited reference list in there, though. Bibliographic coupling map, again, it can analyze documents, sources, authors, organization, countries, but the documents, the nodes are going to be documents from that data set if you're analyzing the documents, and then the lines are going to be links between documents that are based on the number of references they share in their reference list. Co-citation map, you can analyze cited references, cited sources, cited authors. Again, those nodes are going to be documents from the data set, and then the lines are going to link documents based on the number of times they're cited together on those reference lists. You can use a lot of different data sources depending on the map. So we use Scopus, but you can see here different ways that you can use Web of Science, Dimensions, PubMed, Crossref, Europe PMC, Microsoft Academic, Semantic Scholar, Open Citations, Wikidata. There's a lot available to you. I will mention that there are some upcoming courses. There is a course called Bibliometrics and Scientometrics for Research Evaluation. There are two of them being offered. One has US-based times, one has Central European-based times. Caveat, I help organize the US-based one. I'm not an instructor. This is a group, the CWTS group from Leiden University. They're wonderful. They teach the best classes, and I just love to help host one of those in the US. And then also, there is a class in January 2021, Central European-based times, but it's actually on VOSViewer. So if you're liking this and you want to delve into more, there is so much more here to cover than one we can do in just 1 hour. So I just want to say thank you to all of you for your patience in today's class. I know we covered a lot, but I really wanted to get you up and running as fast as you could on VOSViewer. To the CWTS team at Leiden University for providing VOSViewer for us and all of that great help documentation you can refer to. If you have questions, you can always go to www.vosviewer.com/contact. And then I always enjoy seeing how people use VOSViewer or data visualizations in their work. And if you just want some kudos, go ahead, email me your work, and I'll send you back a nice word. So I'm at karen.gutzman@northwestern.edu. So I'm going to go ahead and stop sharing my screen if I can figure that out. I can't figure that out. Yeah, Ling or Chris.
Awesome. Thank you, Karen. So we have a few questions for you. So the first one is that can we export all the clusters information from the left side of the page?
Yes, you would actually use the map file for that. Much easier than trying to export it any other way. So it's all in that map file.
Great. Thank you. The next one is about the self-assigned cluster that you mentioned. So the person asked that, will self-assigned cluster enable you to color nodes as you like?
Yes. So in that map file, you can actually reassign clusters, and I've done that for co-authorship maps where I want to show people from different institutions as a particular color. Just note, though, that those cluster colors are assigned by an algorithm. So once you start making changes, you lose that information that the algorithm was trying to impart, right? It's the same way if you're moving nodes. You're losing the information that the algorithm is trying to impart. And some of us are okay with that for the sake of really trying to visualize something, but it can be super messy in a term co-occurrence map, right? Because you're working with that people now, you're working with terms. So just note of caution if you try to do that.
Mm-hmm. All right. And then there is another question about will VOSViewer connect to OSTI.gov? So it is Office of Scientific and Technical Information. They have a specific data sets. So can people use VOSViewer with that? Or as an alternative, how can one download or edit OSTI.gov data to make it compatible with VOSViewer? Do you have any experiences with that?
Okay, so I don't, and I am not advocating this, but I'm just going to say that, you know, it could be, and I suppose it's the way the data is set up. So when it's taking in data from Scopus, it's looking for data that's shaped exactly the way Scopus has it, with columns, with the same kind of like delimiters and everything. I suppose you could try to reshape the data to make it look like it came from Scopus. I don't think you would have very good success, but I would say, hey, if you want to try it, try it. Otherwise, you know, you might mention it to the VOSViewer crew at CWTS and say, this is a good data source. Can we work on getting it in the tool?
Great. I think the last one is more of a comment than a question. Okay, so it says that it might be interesting to link cluster number to funded government grants and some things.
Yeah, no, go for it. That's really great. I mean, try all these different things. Just, you know, I refer you back to the manual if you have any questions about why things are laid out the way they are, colored the way they are. But, you know, go ahead. The world's your oyster, I guess. So.
Awesome. I think that's all from my end. Thank you again, Karen.
All right, thanks.
Great. Thank you again, Karen. That was really fantastic. It was exactly what we were hoping for. So thank you very much for doing that. So that concludes our programming for today. Thank you all very much for hanging in there with us. And thank you for being so active and involved in participation and asking questions in the chat, looking in the Slack channels. It was great. As a reminder, we do have another poster session tomorrow morning at 11. There are some really great posters in Slack, so definitely do keep that going. And we'll see you all back here tomorrow at 12 noon Eastern. Thank you all very much.
Thank you. Have a good one, everyone.